Section 3.5. 3.4.
Yeah, I have an extra secret squared somewhere.
So, section 3.4, and you're like 31 and
33.
33. All right. I like it.
And then the 2 on the other.
And then the 2 from the sheet, right? I remember 21 from the sheet and
I have an extra secret somewhere. I don't know.
Ben. 21 and 23. What? Hey, good evening, everyone. First thing is, there's a typo on those solutions. Typo. The answer, the number 23, in the chain rule practice. Any parentheses that has a 4x should say parentheses 5x. Any parentheses where you see 4x, you replace it with 5x. There's 2 places, do you see it? That's the chain rule practice, the solutions. Any 4, just make it a 5. Typos. Or 5. Okay, why does 5 turn into a 4? Now, we'll work that problem. Okay? But before we do 23, let's do 21. From the chain rule practice. So this chain rule practice. Okay. Practice on chain rule. Okay. Practice on chain rule. Number 21. F of x equals x times the square root of 2x plus 1. What's the overriding rule I should use?
2x minus 1, I think.
Oh, you're the best, is it?
Mm-hmm.
Thanks a lot. 2x minus 1.
You can
Honest
use
rule. Product rule. We got to start with product rule. In front of square root 2x minus 1, we have x. Now, if it was just a 5, we would not need product rule because it's a constant. If there's an x in front of square root 2x minus 1, we got to think of this as product rule. So, here your m, your n, f prime, m times n prime, plus n times n prime. I think 3 of these are a piece of cake. What's m?
x.
What's n?
2x minus 1, 2 to the power half.
What's n prime?
1.
I'll even write it. Just so you know there's something there, 1. 3 out of 4, we're like, ba, 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 done. And then you're like, whoa. And if you have to, go off to the side to say, listen, if n is equal to the square root of 2x minus 1, which is 2x minus 1 to the 1/2 power, what's that derivative? Right? The half comes in front. This is chain rule. And then we decrease this by 1, and I substitute g back in there. There's g.
2x. 2.
A lot of students think that's a derivative, but you won't. It's like 1/2 in front, decrease this by 1, now multiply the chain. What is, there's g. What's the derivative? What's g prime there? What's the derivative? 2x minus 1. Times 2. And when there's that g prime chain we're always talking about. Now you can cancel
2
before I
and
shove it up in there.
2.5.
And this 2's come out. And then isn't that 1 over a radical 2x minus 1? So I'm going to write it nice and clean. Here it is. That 2 cancel with that 2. There you go. So now I'm going to put it back in here. Over square root 2x minus 1. Yeah, I'm done. But everyone, it's good to write an answer with a solo fraction. So from here on out, it's just algebra. Common denominators and things like that. So let me write this again. X over square root of 2x minus 1 plus square root of 2x. I'm done. Now I'm going to write this one fraction. Common denominators. Well, that has a square root of 2x minus 1 in it, right? This is over a what?
1.
1. So how can I make these common? Just go over to this guy and multiply what? Since this is over 1, just multiply a square root of 2x minus 1 over a square root of 2x minus 1. And you now have common denominators. I got to put the parentheses, but I thought I would. So that's 1. And you'll notice this looks really neat now. Yeah, and when the common denominator is this. But look what you've got in the numerator now. You've got x plus, and what's 2 squared root of 2x minus 1s multiplied by each other?
2x minus 1.
And do you see how you can leave this answer? You got like terms in it. Like terms, 3x minus 1 over. Ta-da! Lot neater than that other expression. Good job. Let's do 23. Oh, we're just noting that the solutions to number 23, there was a typo. If you see any parentheses that had a 4x, 5x, we'll work it now so you can see the actual answer. So you got sine, is that cubed? Sine cubed x. Tangent 5. Hey, do you all agree? Let's do product rule.
Mm-hmm.
So I'll leave this up to here. M times m prime plus n times m prime. Your m, your n. This time I think 2 are real easy. What goes right here?
Sine cube x.
Sine cube x. Everyone, if you didn't know this, when we write sine cubed x like this, that means sine of x all in a parentheses cubed. That means 3 sine x's. Sine x times sine x times sine x. Just to make that note, it's just an easier way to write it. This end over here is tangent 5x. But I think we should go off to the side and figure out these other derivatives. m equaled sine cube x. Can I think of it like that? Right? Let's find m product. All right, Kel, it looks like the chain rule. 3 comes in front. Looks like a chain rule. Decrease all this by 1. Put your g back in. G was? Now multiply g prime. What's the derivative of just a sine of x? Got it. There it is. That's it. That's m prime. Is everyone okay with that? That's chain rule. 3 sine x to the second, multiply derivative of sine x, which is cosine x. So that all goes on m prime over here. Alright, so I'll put a big parentheses and just go 3 sine, you know that's an easy way to write that, cosine x. Okay, we took care of all that. Let's take care of that m. Oh, this is going to be a lot easier. But it is chain rule. Now by chain rule, we know the derivative of tangent of x is secant squared of x. So this will be secant squared of 5x times your g prime. Everyone hear that? G prime is 5, and I like to put it in front like you do. Problem done? 5 tangent squared 5x. And now you'll note those typos that I had. I had 4 x's in there on the original document. These are 5 x's. That's it. But is there anything nice we can do? It's always good to get those coefficients way out in front. See this 5?
I think you made a mistake.
Oh, it's secant squared. Thank you so much. All right, you're the best. He's like, hey, the derivative of tangent is secant squared. Thanks again. And the final answer, I'm just going to put the 5 out in front of all that stuff. 5 times sine cube x times secant squared of 5x. There's the plus, then there's a 3. 3, and you could do what? Sine squared x, there's a tangent 5x, and there's this cosine x. Well, it really doesn't matter the order. I'll do that, then I'll do that, then I'll do that. I guess there's one thing we could factor out of it if you wanted to. What could you factor out? Sine squared? Sine squared of x? Good. So if you want to factor out, that's why on the solution document I wrote it 2 different ways. If the student preferred to factor out that sine squared of x. Okay with all that? Oh, awesome. You'll know, we just get more and more practice with chain rule. More and more practice with chain rule. A couple more, because I know you wanted to do a couple textbook problems. We'll do those.
I have one other question. How do you get secant squared?
Oh, it's just, if you want to, we can prove it. But you know sine's derivative is cosine, right?
Yeah.
But it came from, like, oh, maybe we should memorize these. It helps. But if you wanted to see it mathematically proven, you could call tangents sine over cosine and do like quotient rule. And you'd come out with that.
Okay.
But that's what it is. Secant squared of x. That's the derivative of that one. Well, man, anybody remember the derivative of secant?
Secant x tan x.
Secant x, tan x. Secant x, tan x. And so I know that they don't come up as often as the sine and the cosine, but we do, there's derivative of tangent of x or secant of x every once in a while. All right. Now, textbook, number 31. How about this guy? I want to try to get this derivative. Sine of tan of 2. Okay, let's start it. F prime would be
Cosine
cosine of,
tan of 2x.
I'll put my g in, and then I'll do g prime. I'm gonna put your g back in. Stick it back in there. Tan of 2x. But chain rule means I need to get the derivative of that. Multiply. Which involves another chain rule. What's the derivative of tangent of 2x?
So
Secant squared of 2x times a what?
2.
By chain rule, times a 2. Just like before, I want to look at that one. Did anyone see that? If you get that one, you get chain rule. Because it's like a double chain in there, isn't it? If you get that problem, you're like, all right, sine of blah. Okay, cosine of, put my g back in, times g prime. But you're like, but how do I get that type of derivative? Well, that involves chain. Find the derivative of tangent 2x, it's similar to this. Let me get that. So final answer, I'll just put the 2 in front. 2 cosine tan of 2x multiplied by secant squared of 2x. Awesome.
Didn't we miss an extra 2?
Did we? Where would you think?
Well, if you take the derivative of... Oh, no, never mind.
Good call. See, you saw it. It's neat because it's like, here's that f of g, right? And you're like, you're g. And so we did sine, cosine, put g back in. And then we just had to multiply